Hi everyone, Steven here. If you're like me and you set up a vSAN express storage architecture and ESA architecture, and you started creating some VMs and you wondered, what happened to my witness? What's with all these extra components? Stick around, that's what we're going to talk about. See you in a bit. Thanks for sticking around, everyone. If you notice, I changed my shirt real quick. Anyways, so what we're going to do is we're going to take a look at the changes that are made when we talk about components or objects and components and stuff. When we look at the new express storage architecture, there's also something I kind of noticed, which is a little weird. I don't have the answer for it yet, but you got to stick around towards the end to see that. It's kind of weird, but anyways, let's jump into it. So I always like to throw this out at this point. For those of you that subscribe to the channel, thanks very much. I really appreciate it. For those of you that, again, you haven't subscribed to the channel, please support the channel by subscribing to it. If this is stuff that you're interested in, I try to get out a couple videos a week. I'd really appreciate it. Also, another way to support the channel, I have super thanks enabled. That's totally up to you. So enough of that, let's jump right into it. So let me get my iPad going here. So there's a bit of a lecture component here, not much, and then there's a demo component, okay? So when we start off here, first of all, just my first thing, I want just a real quick review on what the express storage architecture is. Now, if you don't know any of this stuff that I'm talking about, you need to watch my vSAN 101, okay, the very first part one. But anyways, so the express storage architecture in vSAN, one of the things that we noticed, okay, first I got my boot disk, okay, great. The first thing I want to point out here is we don't have a cache tier. We don't have disk groups. A disk group would normally have a cache device for cache tier, then capacity devices for capacity tier. And that capacity could be solid state or spindle disk, hard drives, right? ESA changed all that. They got rid of all that. There's no more storage group. It's just a storage pool. So all those disks inside your servers, you just say, I want to use this as my pool. Boom, and that's it. None of these are cached. So there isn't a dedicated disk for cache, which is kind of wasteful when you think of it. Probably not the most optimal way to be doing caching, but you know, it's great for the original architecture. It was great, but I think moving forward, this is kind of the way to go. This only works again on vSAN ready nodes today, so this has a much more strict hardware compatibility list to do this, okay? Also, again, I've seen you need at least 25 gigabits per second for your network. I actually seen one situation where they supported 10 gig, but anyways, make sure all your hardware in production, who cares about a lab environment, right? In production, this stuff's got to be supported, even the disks, okay? So that's one of the massive changes here. There's no more cache tier and storage tier. So all the disks inside the server can actually be utilized. And technically, there's really no upper limit on the number of drives, okay? And this is what represents our data store. So again, just a real quick shake and bake review. So again, only SSD or NVMe drives are supported. Now, when we look at our components, first of all, with express storage architecture, we introduced a new component. Again, because we no longer have that cache device, we introduced this thing called a performance leg. Every object that makes up your VM, so like your virtual disk, the home, that type of thing, the virtual machine swap file, all that type of stuff, those are objects. These objects, this is basic vSAN 101, these objects will be made up of components. So now every object will have a capacity component and a performance component. So we kind of see this here. All writes go to the performance leg first. So when this VM is writing to its disk or its capacity, it's going to hit this performance leg. Then once we have a full stripe written to that performance leg, we will basically offload it to the capacity leg at that point. Okay? So just keep that in mind. All your writes go through like this. Okay? Now, how many of these again, this is a very oversimplified diagram, but how many components are made up of this performance leg and capacity leg? Well, it depends on your storage policy. So for your performance leg, if you've got a failure to tolerate a 0, you're doing RAID 0, you're only going to have one performance component. We don't really care about redundancy, right? So you're probably not doing that. Let's scratch that off. If you've got a failure to tolerate a 1 and you're doing mirroring, you're going to have 2 child components. A way to calculate how many components in the performance leg you'll have is based on the failure to tolerate plus 1. So if I got a failure to tolerate a 1, I will have 1 plus 1, 2 components. Here's another one, failure to tolerate a 1 using RAID 5. I would have 2 components for that performance leg. I'm doing failure to tolerate of 2. I would have 3 components. And I'll show you some graphicals of this. And failure to tolerate of 3, I would have 4 components. So this performance leg could be split up into up to 4 different components that we're mirroring. The capacity leg, if you didn't watch my striping video, you need to watch my striping video to understand this. The capacity leg will take that component and split it into RAID 0 components, like striping, when I talked about my striping. So RAID 0 and RAID 1 will basically have 3 child components. RAIDs 5 and 6 will have 2 child components. And I got diagrams of this coming up right now. So let's take a look at this. Let's look at a failure to tolerate a 1, and you're doing mirroring. And this is for express storage architecture. This is not the original storage architecture, vSAN. So we'll see, here's my VM. Let's say it's 100 gig in size. So this component would be 100 gig and 100 gig. And what they did underneath the covers is they said, let's stripe this out. We're going to make 3 separate. So this is probably 33.3 gig, 33.3, 33.3. We're going to take this component and break it down into 3, we'll call them subcomponents. And we're going to do RAID 0 across that. So we're striping, and you see that. So this one component will be thrown on this disk, this one will be thrown on that disk, this one is thrown on this disk. And we do the same thing over here, okay? These are a mirror. So again, we're going to break this down into 3 subcomponents like striping, and we'll spread them across 3 different disks. That's the whole point of it. It's silly to put it across the same disk, to be honest with you, right? So we're striping it across. So this happens automatically for you, which is kind of cool. Now the performance leg, remember we write to the performance leg first. So RAID 1, failure to tolerate a 1 plus 1, so 1 plus 1 is 2. I'll have 2 components here. So we take this performance leg, our writes going into the performance leg, and that write will go to this component and this component. It's a mirror of each other. Why do we do that? Because if this fails, we still got our write, okay? So notice again, this one is put over here in this example. This one's here. You might think, well, hey, Steve, why didn't it put that other P1 right there? That would be silly, because if that server died, you just lost all your writes. So the performance leg is going to be striped across fault domains across your servers, so you don't have that single point of failure. So like I said, when the write comes into the VM, it gets hit to there, sorry. The write will go to the performance leg first. These guys are mirrored, okay? Then when we get that full stripe of that stripe has been written to it, the full stripe, we'll then offload that to the capacity tier at that point. Okay, so this can help with performance. Okay, this may not seem like a big deal too much with RAID 1. Let's look at RAID 5. Okay, so failure to tolerate 1. So failure to tolerate 1 plus 1 is 2, so we'll have 2 performance legs. Now, RAID 5, as I mentioned before, again, watch my my vSAN videos, but RAID 5, we stripe information across the components. So we'll have component 1, 2, and 3. And we're going to stripe the information across it. So you have data 1, data 2, and then a parity. And then we skew the parity. This is RAID 5. So that's what we're doing with these components. We're taking our data, striping it across, data, parity, and this is how we have this failure to tolerate a 1. Okay, watch my, again, vSAN videos on that, right? Now, the downside of RAID 5, okay, one, you save space, okay, compared to RAID 1. Which I talked about, but the downside of it is on writes, because when you go to write stuff out, I'm going to write data 1, I'm going to write data 2. This parity you need to calculate. Your server has to calculate what that value is going to be. That takes time. That's a performance hit. So this is why you'll generally hear like RAID 5 usually suffers with write performance. So RAID 5 is not the greatest when you're doing lots of writes. If performance is your main concern, RAID 5 is something you don't want to. The cool thing about this architecture is my writes don't go out to here directly. They go to the performance leg, which I'm doing a mirror. I'm doing RAID 1 across that. I don't have that penalty now. So I write my data to the performance legs. They're mirrored, okay? And then when I have that full stripe been written to it, I then offload that to the capacity tier, right? And that's where I can kind of take my time. So once it's been written to the performance tier, we acknowledge the write. Thank you very much. Go on with the next thing. So this, like, I don't have any performance numbers, but this should blow away in performance a RAID 5 of the original storage architecture compared to this, okay? So that's actually really, really cool. So you see in this example here, we got our performance leg again on different servers, okay? Again, we did our capacity here, and we split that into two. Remember I said you'll have up to two components. So we're taking this capacity and splitting it across these two drives. So we're technically potentially increasing performance there on that as well, okay? Especially for reads, because reads we go right out to the capacity, so we're automatically striping at this point. So your performance should be a lot better. This is with 3 to 5 hosts. Now, if you watched my what's new in ESA video, that was, I think, part 1-A. It was an amendment. I talked about the adaptive RAID 5. If you've got 3 to 5 hosts, this is what it does. It does a basically 2 plus 1. So 2 datas to 1 parity configuration, so minimum of 3 servers. Unlike the original storage architecture, you needed a minimum of 4 servers. It was a 3 plus 1 parity, right? And you didn't have a choice there. With this adaptive RAID 5, once you have 6 or more hosts, or let's say this is how I started, and then I add another 3 more hosts, in about 24 hours, it will restripe everything, and this is what it would look like. We'll now have a 4 plus 1, 4 datas, and 1 parity, okay? So you see all the components we now have. A lot more components, a lot more stripes. And again, we still have our 2 performance legs here, okay? So so this is what we should see. Now, one thing I want to, and let's look at RAID 6. I'm going to show you all this. RAID 6 now, this would be a 4 plus 2, so you need a minimum of 6 servers. RAID 6 now, again, 4 plus 2, 4 data, 2 parities. RAID 6 generally depends on how it's implemented. I remember teaching my stuff on the servers, on the IBM servers back in the day when IBM did have servers, Intel servers. We implemented a RAID 6, and there was different ways you could generate these parity. The first one they would have to calculate, and then the second one they could just do a simple mirror, or they could just do another calculation, right? So anyways, bottom line was RAID 6's performance is potentially a lot worse than RAID 5 because of the double parity, but you can lose up to 2 servers and still be okay. So that was kind of cool. Now with ESA, this is really neat. I like this part with the extended storage architecture, express storage architecture. We got a failure to tolerate a 2, so 2 plus 1 gives us 3 components for our performance leg. So we're writing out to here, and then when we complete the stripe, then we offload it to the capacity tier, right, or capacity leg. And essentially this completely eliminates that performance issue that you would have with RAID 6. So that's really cool. I really like this. That's the space efficiency. So this kind of brings the best of both worlds together: performance from a writes perspective and efficiency for storage. Right now, I'm going to back up one more. Let's go back to the RAID 1 here. Now, if you looked at my vSAN video, vSAN 101, when I talked about RAID 1, we had component, then a witness component. I don't see a witness component here. So this is basically what you may notice in your environment. You go, what happened to my witness component? Something's wrong, something's broken. Well, they could use these performance legs as witnesses now, if that kind of makes sense, okay? So generally speaking, when you're doing a failure to tolerate of 1 and you're doing mirroring, you generally don't see a witness leg there, or I don't want to say shouldn't. You more than likely will not see a witness leg, witness component, and that's okay because we could use the performance component to do that for us, right? Yeah, and now I didn't do any slides on failure to tolerate a 2 with mirroring or 3, but again, it's basically the same kind of thing, right? The failure to tolerate a 2 mirroring, you need 3 performance legs. Failure to tolerate a 3, you need 4 performance legs, and so on. Very, very similar. You can kind of play with that. So let's take a look at this now, okay? So let me just get to my screen over here. Okay, so we're back. I already created a couple of VMs here. I've got about 5 servers here. I'll do a video on setting up an ESA cluster. But for the most part, I already created some VMs. And my first VM here, let's look at the storage policy on it. If I actually look at policies, you'll see I'm using the vSAN default storage policy, which is failure to tolerate equals 1. No problems. So I'm going to go into monitor, and I'll go into physical displacement. And so what do I see here? I see a bunch, and I don't have the VM powered on, but I have my hard disk over here. Let's collapse that. Then you have the virtual machine home. That's the VMX. And you don't see the swap because I don't have it turned on. Let's turn it on. We have to refresh this. Let's minimize. Come on, minimize. There's this swap and then the home. So you see the swap there's because I turned it on. Let's look at the hard drive. That's what I care about. So you'll see the first thing you see, this RAID 1. Okay, this is failure to tolerate is 1 and we're mirroring. So the first thing you see, the very top 2 components, okay, these are RAID 1 components and there's your 2 performance legs, okay? There's the performance components. Then you see the RAID 1 over here and you see the RAID 1 is made up of 2 RAID 0 components. These RAID 0 components are made up of 3 components each, just like I showed you. So there's my 3, RAID 0, and then we RAID 1 them together. Let's go back to the iPad. Basically what I'm showing you here. There's the 3 for that component, the 3 for this component, and then we RAID 1 those. Okay, and that's what we're seeing here. And the 2 RAID 1s was basically my performance leg. Let's go back to there. There we see that. There's the 2 RAID 1s. Okay? I don't see a witness component. Okay? Stay tuned on that one. I did say I noticed something weird. Stay tuned on that one. Okay? So that's cool. Let's do a failure to tolerate of 2. All right? So failure to tolerate a 2. What do I see? Hang on a second. Failure to tolerate a 2. I add 1 to it. So there's 3. Therefore, I'll have 3 performance legs. So the first thing you see is your RAID 1. You got 3 component legs. There's your performance legs right there. That's for my hard drive. Let's minimize that. I'm doing failure to tolerate a 2, so I got a RAID 1 of 3 devices. So these are my 3 RAID 0s here. Okay, this is made up of 3 components, another one made up of 3 components, and another one made up of 3 components. I'm basically doing a 3-way mirror. So if I lose 2 hosts, I'm still okay. And the reason why, but if you look here, why did we have 3 components for the performance leg as opposed to 2 like we had just the RAID 1? Well, remember, I can say fail to tolerate a 2 host. If I only had 2 performance legs, and just by chance, if I lost 2 of those hosts where the performance legs were on, I lost my rights. Think of it as, when I think of rights here, I think of like a RAID controller that has cache on it, and you do a write back. Basically, your writes go through the cache, and that's really fast. And the cache stores it and says, okay, the write's done. And then when the controller gets a chance, it writes it out to the slow hard drives. That's how we used to do it. Well, generally, we can still do that today, right? So this is how I look at this performance leg. It's almost like a fast, high-speed cache. And the cool thing about it, it's not a single disk like the original storage architecture. These 3 components you'll see are on 3 different servers on 3 different drives, right? So I'm not like in the original storage architecture, generally you had that 1 cache component per disk group, and that could potentially be a bottleneck, whereas this one, it could be across any drives, okay, which is nice. Let's look at a RAID 5 hosts. Or a RAID 5 VM here. So RAID 5, let's go back. Okay, so RAID 5, failure to tolerate a 1, so I'll have 1 plus 1 is 2. Also I'll have 2 performance leg components, which I do. There's the 2 RAID 1s. And then here's my RAID 5. Notice, again, it's got, let's minimize this. This is doing a 2 plus 1, okay, because I did this with just 3 hosts, 2 plus 1. So you'll actually see it taken each component and made it to 2 different component stripes. So this is a RAID 0. So technically this is doing really a RAID 50 or 50 if you want to call it, right? So let's go back to my iPad and let's look at that. There it is. There's your RAID 5 across 3 hosts, 2 components each. We're doing RAID 0 across those. Then we're mirroring. We're doing a 3-way mirror. Sorry, this is RAID 5. Then we're doing RAID 5. RAID 5 across that. Okay? And then here's our 2 performance legs, as I mentioned before. And the performance legs you'll never, again, see on the same host, because that would be silly. Because think of the performance leg as, this is my write cache. Okay? So you write in it, and if you lost both of them, you just lost that write. And that wouldn't be a good thing. Okay? And that's about it. Okay, there's one more thing I wanted to show everybody. So let's go into my screen over here. I deployed a few more VMs, and I'm just going to create a new one here. Actually, before we do that, let's look at my RAID 1 VM, right? So my RAID 1 VM, if I go monitor displacement, again, there's the performance leg. Let's get that out of the way. Then here's my capacity leg. So it's a RAID 0 with 3 components. Let's minimize this. It's another RAID 0 with 3 components. You don't see witness components here, okay? There is no witness components. I could actually show you probably a little bit clearer if I go to, let's go into the Ruby views for console, ls. VM1 is number 2, right? So, so let's do the number 2. You'll actually see, again, there's my RAID 1 of these 2 RAID 0 components. You don't see a witness. Okay, if I go in and look at my, actually let's look at this here. What VM we're looking at? Failure tolerated 2, a mirror. That's a VM number 4, right? So let's look at the objects for number 4. If I look at number 4, again, I got my performance objects, my performance leg. Then I have I did a failure to tolerate a 2. It says right up here, host failure to tolerate is 2. So you'll see I've got a mirror, a 3-way mirror. I got a RAID 0 of 3 components, another RAID 0 of 3 components, another RAID 0 of 3 components. You don't see a witness, okay? Great, let me show you this now. Let's go back into here. Let's create a new VM, new virtual machine. Next, I'll call this VM 8 or whatever. Next. I'll pick, I want to do failure tolerate 2. Let's go next. ESA, Windows, good enough. I will finish. Give it a few seconds. Let's hope this doesn't make a liar out of me. VM8. Let's just look real quick. There we go. Okay, that's exactly what I wanted to see. All right, let's look at this. LS. VM8 is number 8. It's at the very bottom there. Okay. So let's look at that. 8. So same kind of thing for performance leg, 3 components, 3-way mirror. Then we have a RAID 1 of multiple RAID 0 components. So we got a RAID 0 component of these 3, another RAID 0 of these 3, another RAID 0 of these 3. So we're doing RAID 10 across those. Whoa, there's a witness there. What the heck's going on, right? So I've run into this a couple of times, and it didn't have to be failure to tolerate of 2. I did it with a failure to tolerate of 1. And I think it has to do, again, I'm not 100% sure. If you know the answer, leave it in the comments down below. But I'm speculating. 1, I don't have the disk requirements for a supported vSAN environment here. And I think it's having a hard time finding placement of all these components and stripes. And it says, okay, I can't do that. I can't create, I got to create a witness component to protect you, right? So witnesses, from what I can see, are not completely gone. Okay, I had to create a bunch of VMs to kind of fill things up before it started to use a witness here. Again, witnesses are not used on RAID 5 and RAID 6, only on the mirroring stuff. Failure to tolerate a 1, 2, and 3, mirroring. Okay, that's when you might see a witness. But generally, again, I don't have enough storage here, and I think that's the reason why it's doing it. I'm not 100% sure. But anyways, folks, that's it. I hope you've liked this video. Hope you found it informative. If so, hit that thumbs up. Subscribe to the channel also. That will support the channel. And for those of you that already have subscribed, thank you very much. Leave comments and questions down below. Please don't send questions to my LinkedIn. I'll just use that for professional connecting to me if you want to kind of gig or whatever like that. But leave questions in the comments. This way everybody gets to see the questions and the answers. But that's it. Thanks very much. Let me know if you want to see something else in the future. I'll see what I can do, and have a great day. Bye now.